Imagine time and space as a big stretchy fabric, like a rubber trampoline. Now, imagine twisting that trampoline into the shape of a pretzel. What if that twist could let you travel back in time? Have you ever wondered what secrets are out there in the universe? What amazing mysteries it might be hiding? You're about to find out something so incredible it could change everything we thought we knew about space. Get ready as the famous American physicist Michio Kaku reveals a groundbreaking discovery made by the legendary James Webb Space Telescope. This discovery might prove that time doesn't even exist. Ready to dive into a space-time puzzle that will blow your mind? The James Webb Space Telescope is essentially the Hubble Space Telescope's bigger, cooler sibling. Launched on Christmas Day 2021, this telescope has taken up residence in space, illuminating secrets from the universe's darkest and most distant corners. It's like the ultimate time machine, equipped with super powerful infrared instruments that make it perfect for peeping into the past. How, you ask? Well, its unprecedented resolution and sensitivity allow it to detect incredibly old and faint objects that even Hubble couldn't glimpse. We're talking about distant galaxies and celestial bodies from the early universe, those elusive entities that have been playing an epic cosmic hide-and-seek with us. In essence, James Webb is helping us piece together the universe's grand star-studded jigsaw puzzle, one infrared image at a time. Now imagine you're at an art gallery, strolling past grand pictures captured by the James Webb Space Telescope, also known as JWST. The imagery is breathtaking, with distant galaxies shimmering across the cosmic canvas. Yet, among the astronomers and cosmologists, you see shock and disbelief. There's a sense of turmoil, almost as if they're staring at a Picasso in a room full of realists. The common phrase you hear is, "This is unexpected." So what's the fuss all about? What's rattled the very foundation of their understanding of the cosmos? Although the official papers are tight-lipped about it, the real issue lies with a theory they hold dear: the Big Bang hypothesis. This is the idea that our universe kicked off in a massive explosion about 14 billion years ago and has been expanding like a giant balloon ever since. This theory has been the cornerstone of cosmological understanding for years, and now the new images from the JWST seem to question its validity, sending shockwaves through the community. You can almost hear Alison Kirkpatrick, a seasoned astronomer from the University of Kansas, tossing and turning in her bed, questioning her life's work. Why is everyone so surprised? Well, the galaxies captured by the JWST aren't behaving as they should according to the Big Bang hypothesis. They're too small, too smooth, too old, and there are way too many of them. Let's try to simplify the too small conundrum. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start looking bigger because their light supposedly left them when they were closer. It's a weird but essential twist in the expanding universe concept. Yet the images from the JWST show galaxies that are about the same size as the ones near us. It's like you're expecting your distant friends to appear as tiny dots on the horizon, but instead, they're right next to you, just as large as life. Interestingly, they show galaxies appearing smaller than we'd expect, even those that shine brighter and pack more mass than our own Milky Way. These pictures show galaxies that seem to be 2 to 3 times smaller than the ones seen through the Hubble Space Telescope, HST, despite their greater luminosity and mass. Additionally, these galaxies also have significantly higher redshifts, which in layman's terms means they're supposedly moving away from us at faster speeds. You might think, well, that's odd. And you'd be right, especially if you're operating under the assumption that we live in an ever-expanding universe. A while back, in 2014, some scientists had already pointed out this inconsistency. They analyzed HST images and found that galaxies with redshifts up to 5 seemed to match what you'd expect in a non-expanding typical space. It was anticipated that the JWST would continue this trend, and it has, even for galaxies with redshifts as high as 12. In simpler words, the JWST images show galaxies that appear the same size as those close to us, as if the universe isn't expanding and redshift is merely a function of distance. But if we still cling to the Big Bang Theory and its expanding universe concept, we're left with a pretty perplexing conclusion. These distant galaxies must be unimaginably small to counterbalance the supposed optical illusion created by an expanding universe. It's a bit like finding your friend's tiny dot on the horizon, only to realize they're right next to you, full-sized and impossible to reconcile with the expected perspective of an expanding universe. Tiny galaxies are like imagining a grain of sand with the brightness of a spotlight. Take, for instance, a galaxy named GHZ2 that the JWST spotted. It's far brighter than the Milky Way, but is calculated to be only 300 light-years in radius. Compare that to the Milky Way's 50,000 light-year radius. Its brightness per unit area would be 600 times that of the brightest galaxy in our local universe. Not just that, its density and that of several other new galaxies would be tens of thousands of times higher than the galaxies we see around us today. When you consider these tiny and smooth galaxies, the notion of an expanding universe, and by extension, the Big Bang Theory starts to crumble. That's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, the Hubble Space Telescope images have given them a hard time. The pictures suggest the existence of many galaxies dense and powerful, much like Mighty Mouse from old cartoons. These galaxies are a challenging puzzle for them, and with the new James Webb Space Telescope, things have only gotten trickier. To make sense of these peculiarly tiny galaxies, theorists have put forth an idea. It's as if you're playing with a tiny toy car, a magical one, which despite being only a centimeter long, weighs as much as an actual SUV. They suggest that these microgalaxies collide into each other over billions of years, merging to form the full-sized galaxies we see today. It's like the toy cars colliding and growing up to be real SUVs. But here's the twist. The JWST has taken a close look at these galaxies and found no signs of such cosmic car crashes. You would expect these colliding galaxies to show some signs of damage, right? Maybe look a bit scrambled or mangled like a car after a fender bender, but that's not what we see. Instead, the JWST reveals galaxies that are smooth, neat spirals just like the ones we see nearby. There's an overwhelming lack of galactic fender dents. In fact, one study aptly titled Panic highlights that there are 10 times more of these pristine spiral galaxies than the theorists had predicted. This is akin to finding a busy highway with speeding cars, but no accidents. It's a pretty significant blow to the collision theory. With no signs of galactic mergers, the idea that these tiny galaxies somehow expanded into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Consequently, the optical illusion we'd expect from an expanding universe doesn't seem to be there. Without this illusion, the concept of expansion loses ground, hence the growing unease among Big Bang enthusiasts. The appearance of these small and smooth galaxies suggests that the universe may not be expanding, and if it isn't, the Big Bang Theory takes a major hit. There's another aspect to consider: the age of stars. The Big Bang Theory suggests that everything came into existence following the big explosion. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game-changer for our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine. In the words of Michio Kaku, it can peer billions of years back into the cosmos, capturing images that shed light on the universe's origins. This incredible device isn't snapping photos in our familiar visual spectrum, though. Instead, it's focused on the infrared, revealing colors of galaxies so distant we could never observe them with our naked eye. Now here's the fascinating part. These colors aren't just beautiful. They're telling a story about the age of the stars in these galaxies. Young, fiery stars blaze a vivid blue, while their older, cooler counterparts, similar to our sun, glow in hues of yellow and red. By examining these colors, astronomers can estimate the age of the star populations in these distant galaxies. According to the Big Bang Theory, the galaxies farthest away in the JWST images represent a cosmic snapshot from around 500 million years after the universe's birth. However, some of these galaxies appear to house stars that are over 1 billion years old. Now, if you've been following the Big Bang Theory, you know that's a big problem, because nothing should be older than the Big Bang itself. Another expectation, if the Big Bang Theory is correct, is that as we gaze farther into space, which means looking further back in time, we should see fewer and fewer galaxies until we reach a point where there are none, a cosmic dark age, if you will. However, it seems to be a different story. It seems that galaxies as massive as the Milky Way were already pretty common even a few 100 million years after the supposed Big Bang. The new images indicate that there are at least 100,000 times more galaxies than predicted at high redshifts more than 10. So the question is, how could so many large galaxies form in such a short time? The answer: they probably couldn't, at least not under the constraints of the Big Bang Theory. That's why these discoveries are challenging the foundation of our understanding of the universe. On top of that, there's this intriguing bit of information that suggests the Big Bang Theory may actually be off the mark on quite a few things. Believe it or not, recent research suggests the Big Bang Theory gets 16 predictions wrong. That's right, 16. Friedel, Lee, and Minnick's approach envisions a quantum world with gravity, rather than applying quantum rules to gravity as LQG does. The next big step for them is incorporating time into their model. While this might seem abstract, the implications could transform our daily lives. Our understanding of space-time affects our grasp of both gravity and quantum theory, and a better understanding of the quantum structure of space-time could pave the way for advanced future technologies. The reigning theory of space-time, like any long-standing monarch, might soon be dethroned, and it's high time for fresh contenders. It's tough to predict which theoretical contender will eventually triumph, but when the revolution happens, it could herald a new era of discoveries for theoretical physics. What's the next move for astronomers, scientists, and physicists? Could the James Webb Telescope be the solution to our problems, or might it leave us with more questions? Let us know your thoughts in the comments and stay tuned for more mind-bending videos.